Good morning everyone. Today's video will be about IP addressing, and this is part 2 of our lesson about basic network configuration. To start, let us first define an IP. IP, or Internet Protocol, governs the exchange or transmission of data between devices on different networks. Pag sinabing protocol, ito ay set of rules na sinusunod o dapat sundin. In this case, protocol for data transmission. In the world of computing, there's quite a lot of protocols. Here are some examples. TCP, or Transmission Control Protocol, used for transmission of data from an application to the network. Another example is HTTP, or Hypertext Transfer Protocol, used for sending requests from a web client to a web server. So ito yung ginagamit natin every time na magse-search tayo sa internet. So galing sa atin, send tayo ng request papunta sa web server. So HTTP protocol or Hypertext Transfer Protocol ang ginagamit natin dyan. So, ano naman ang IP address? IP address is a set of numbers identifying a computer or another device on the internet. An IP address can uniquely identify the source and destination of data transmitted with the internet protocol. So, we can compare ang IP address with the traditional mail, kung saan merong nakalagay na physical address kung saan nanggagaling yung sulat at kanino papunta. We have two versions of IPs. The IPv4, which is the more common, and IPv6, which is the newer version. So IPv4 is represented using decimals. Ito yung madalas nating nakikita and ginagamit. And IPv6 is represented in hexadecimal that uses 16 distinct symbols. So 0 to 9 and A to F. For today, we'll be focusing more on IPv4. This IP version has 4 set of numbers and they are divided by 3 dots. Each set of number is called an octet. Octet kasi each set of number has an 8-bit value. So dito sa example nating IP address na 172.16.5.34, pag kinonvert natin siya into binary, makikita natin na meron siyang 8-bit per octet, which is separated by a dot. So an IP address is also divided into 2 segments, the network address and the host address. So I have here an example of a class C IP, which is 172.16.5.34. with a network address of 172.16.5 and host address of .34. Now, the question is the network address always the first 3 octets? And the last octet being the host address? Well, the answer for that is no. You can identify the network and the host address with the use of IP classes. So para mas maintindihan nyo ang network at host address and kung para saan sila, kailangan nating pag-usapan ang iba't ibang classes ng IP. So ganito. Nung unang ginawa ang Internet Protocol, ang first octet lagi ang nagre-represent ng network address. Then, yung sunod na 3 octets ang host address. Ang pinakamalaking value na makukuha natin sa isang octet ay 255. Ibig sabihin, 255 networks lang ang pwede nating gawin. Pero since 3 octets ang para sa host address naman, makakagawa tayo ng nasa 16 million hosts. So, kung titignan, napakakonti ng networks tapos sobrang dami naman ng host address. So, parang hindi balance. Pero tandaan natin na dati, hindi pa naman buong mundo ang gumagamit ng internet. So, ilang malalaking organizations pa lang ang gumagamit nito. So, na-realize ito habang tumatagal at dumadami ang gumagamit ng internet. Obviously, kukulangin yung 255 networks lang para sa buong mundo. So, ang naging solusyon dito ay ang pagkakaroon ng 5 classes of IPs, kung saan Class A, B, and C are used to address devices, and then yung Class D for multicast, and yung Class E is reserved for research purposes. So basically, ang pwedeng gamitin dito is yung Class A, B, at C. So Class A falling or for large networks. And in this example, i-discuss ko kung ilang networks and host ang meron per class, and explain na rin kung paano sila nakuha. So, Class A ay parang kapareho nung diniscuss ko kanina, wherein yung first octet, which is 1, ang magiging network address, and yung 2.3.4 is the host address. Makikita natin na meron siyang 126 networks na magagawa. Pero sabi natin kanina, 255 ang pwedeng gawin sa isang octet. Ngayon, ito ay dahil sa tinatawag na fixed bit. Pag sinabing fixed bit, yung unang bit ay hindi nagbabago ng value. Sa case ng Class A IPs, ang first bit ay dapat laging 0. Dahil dito, 128 lang ang pwede nating makuhang networks. At ang pwede lamang gamitin dito ay 126 dahil ang IPs starting at 0 and 127 ay reserved. So, sa Class B network naman are used for medium-sized network. So, the first 2 octets are for network address, and the third and fourth octets are for the host address. Ang fixed bit naman dito ay yung first 2 bits, which is dapat laging 1 and 0. Kaya makakagawa naman tayo ng 16,384 networks and over 65,000 hosts per network. Now, Class C are for small networks. The first 3 octets are for network address, and the last octet is for the host address. Ang fixed bit naman dito ay yung first 3 bits na dapat ay laging 110 at magbibigay sa atin ng over 2 million networks. Ngayon, dahil 1 octet lang ang natira para sa host address, 254 networks lang ang magagawa natin per network, which is hindi naman masama para sa small networks. Ang Class D and E naman ay naka-reserve. Class D is for multicast, and ang Class E ay ginagamit yan for research and development. IP addresses are assigned in 2 different ways. They can be assigned as static or dynamic. Now, static IP, or also known as dedicated IP, refers to an exclusive IP address that has been assigned to a single user. Dynamic IP naman refers to IPs that keeps changing every time you connect. So, sa static IP, it can be easy to maintain. So, especially for small networks. Pero, humihirap siya pag lumalaki na yung network natin. Kasi bukod sa manual mo siyang ilalagay per computer, kailangan mo din siyang i-monitor in case na magkaroon ng pagdodoble ng IP. So, sa dynamic naman, nagbabago siya every time na mag-login ka sa network. So, most of the ISP providers ay ito ang ginagamit, and they use DHCP server to set a range of IPs na pwedeng gamitin sa isang network. Now, at this point, we know that the internet connects a lot of different networks together, and they are connected using different types of network medias. Now, may idea na tayo kung paano siya physically connected, but what are actually being exchanged through those connections? From the previous lesson, we say that it's signals, but to be more specific, it's called data packets. Now, a packet can be simply defined as a fixed size unit of data. So when you send information over the internet, it is divided into small chunks called packets. Now, we have an image here of an example. So say, for example, you'll be sending an image of this over the network. Now, ang mangyayari is itong image na to ay i-divide into small chunks. So, mapapansin niyo yung small squares. Now, each square represents a data packet. And ito ang sinesend natin over the internet. Now, pagdating sa recipient or dun sa magre-receive ng data, i-rearrange niya or i-recreate niya yung image base dun sa na-receive niya na data packets. Now, a packet is made of two parts. We have the header and the payload. Now, the header is the portion of an IP that precedes its body. It contains addressing and the other data that is required for it to reach its intended destination. Now, the payload is the actual data for each packet sent. So, yung information or yung data natin, nandito siya nakalagay sa payload. And then, yung address information, kung saan nanggaling, kung saan papunta, yun naman yung nandun sa header. Now, we'll talk about how to assign an IP address. This is used when we configure static IPs. So, the first step is by going to the adapter settings. Now, makakapunta tayo dito in two ways. So, we can press Windows R para mag-open yung run, or we can simply search run dun sa search bar natin and then select natin yung run. Once nag-open siya, type natin si ncpa.cpl and then enter. You'll be prompted to your different network connections. So, for newly installed operating systems, by default, wala kayong makikita dito unless nag-install ka na din ng network driver. Okay? So, in this example, we'll use my Wi-Fi network kung saan ako nakakonect ngayon. So, right-click and then select the properties. Dito makikita natin ang IPv4 at ang IPv6 na option. Of course, we'll be using IPv4. So, select natin yan. You will then be prompted to another window. And in this current setting, naka-dynamic siya kasi nakakonect ako sa ISP provider ko. So, meaning, ang nagbibigay sa akin ng IP address is yung DHCP server. So, to switch to static, simply select the use the following IP address na option. And then, pwede ka nang mag-type ng desired IP mo. So, you need to include, of course, the subnet mask and the default gateway and prefer DNS if ever you'll be connecting this computer to a server or a domain controller. Now, this will be further discussed sa ating future topics. Now, to verify naman if you have successfully changed the IP, you can simply open the command prompt. Same thing, using the run button. And then, ang command naman ngayon is yung CMD para mag-open yung ating command line. So, once nag-open ang ating command prompt, i-type natin ang command na ipconfig. And then, syempre, dapat alam natin kung aling network ang tinitignan natin. So, in this example, we used wireless LAN. So, yun ang i-check natin. So, okay. Mukhang okay naman. Ito yung in-input natin na IP address kanina, which is 192.168.1.25. So that's it for today's lesson about IPs, and sana may natutunan kayong bago. Kung may questions, please don't hesitate to contact me through the email and phone number na binigay ko sa inyo. Thanks and goodbye.